Right, so today's talk is called Stately and Composed. So we're going to be talking about state and the new Jetpack library called Composed. We're going to look specifically at how Compose empowers us to push the envelope of UI and UX interaction. So things we're going to learn about today are about state management. We're going to learn a little bit about unidirectional data flow. And we're also going to learn how Jetpack Compose is going to help us keep things efficient while reacting to changes in an application's state. So one thing we won't be doing today, though, is taking a deep dive into creating fancy designs on Compose, user interaction, all of that. That's kind of on the side. Compose is still a pretty beta library at any rate. Like, it is a stabilized API, so you can expect it not to change that much. But as far as like going into the nitty-gritty of animation and things like that, I think at this stage, it's more interesting to look at how will you architect an application with Compose when it hits the beta and the actual release date. So what we're focusing on today is connecting Compose UI with models. And we're going to be covering different ways of doing this because there's not only one way to approach architecture and applications on mobile or elsewhere, as you might very well be aware. So the goal here is to give you knowledge that's going to be useful regardless of what kind of architecture you chose. It could be MVVM, MVI, or what have you. We're going to try to make that stuff useful. Right, so as of early October, things have changed now. Jetpack Compose was in Alpha 4, it's now in Alpha 5, and maybe even in Alpha 6. I'll need to check. Somebody can ask me a question at the end and we'll look. So if you want to try it out, at any rate, what you need to do is get your latest version of Android Studio 4.2, the Canary versions. In those builds, everything in there is ready for you to try and play with Compose. So for folks who might not know, when Google talks of alpha releases like this one, it actually does mean that the API is still a bit in flux. But on the other hand, it means that the fundamentals and the programming model of Compose should be considered pretty solid at this point. Like, a lot of work went into this during the spring and summer. And at this stage, what we're going to look at today is likely not to change all that much before release. All right, so practical examples are really an awesome way to learn. And so for this talk, I've framed the code samples mostly around a fictional native client app that we're going to use to showcase various products. So we're just going to look a little bit at the ideas behind that app here. So we're going to have a product entity, something pretty generic. It's going to have a UUID, a name, a description, an image URL, because we need to show something to make that example interesting a little bit, and a price. So I want you to note the choice of using data class here. So that choice ensures that the model we're going to be passing around is immutable. Not only that, but we've added the actual @immutable annotation on top. You might wonder what that's for. And this is a hint for Compose specifically. It helps Compose keep things optimal when it's going to be kicking into action and basically consuming our product objects. Right, so this is our first composable. So it's the product card here. So inside this product card, we have what's called a column. A column is a way of doing layout in Compose. It's one of the simpler ways. In this column, we start off with a hero image. And now you might notice in the code right here that we're using something called coil image. So coil, as you might or not know, is a new image loading library that's backed by coroutines and is written in Kotlin entirely. So it's the hot new image loading library. It's pretty cool. There's an ADB podcast about it that was, I think, recorded sometime in October. So if you're curious about it, they go into a really deep dive into that. That's really interesting to listen to. And you can learn about what makes Coil special and cool and awesome. Now, Chris Baines has made a small add-on library to Coil that allows us to use Coil as here an image loader. So you can see that we have in our composable, under the column, the first thing we have is this Coil image that takes in a product image URL. We give it a few parameters on how to actually size up that image and play with it a little bit. And you might note as well that we have a small clip command that we have in there. Now, I'll beg for you to be patient with me 1 second. I forgot that I have this nice little tool here that allows me to highlight some of the things that we're going to be looking at on the slides. And I think it's sort of worthwhile bringing it out. So it'll be only a second before going forward. That's some of the benefits of being as ready as I usually am. So is this working? Yes. All right. So let me just double check. So I was talking about this coil image block. Yeah, there we go. And specifically what I wanted to point out was how the preferred height and clip right there is specified straight on using this modifier object that we pass in. Right, so that's kind of one of the nice features of Compose. You can specify layout very intuitively that way. And then we have, like, to complete the example, we have a spacer right there. We have we have a bit of, there we go. We have a bit of, there we go, technology, isn't it great? All right. All right, my presentation's being very picky. I'll stop playing around with it, I swear. All right, cool. So we have spacers, we have text blocks right there. And so you can see it on the card right there. You can see how the spacers act and how the layout is being done and how everything works out pretty nicely. All right, one of the small details I like about this is right there, how we can specify what to do when there's too much text on the card, right? So there's a lot of information there, but we'll skip over that. I promised that this would not be a long-winded talk about how to make nice UIs, of which this is not one. All right, so the things to know how things work right here. So by being written in Kotlin instead of XML, one of the main advantages of Compose is that the Compose functions can be as dynamic as they need to be, and that's one of the key points here. You can set up very sophisticated behavior. So in this simple example I have on this slide, what we're doing is we're sorting the product list that was passed in, and how it takes the only the top 2 items from it is shown on screen. All right, so let me just like go over this. So right here, what we're doing is like when we're setting the content, right? The product top list right here takes as a parameter the number of products that we want, and we're passing in the actual full list. And in there, in product top, in this function, what we get to do is like we take our list of products, we take some parameters, obviously, and then right here, what we can do is like in products, we can decide that it's sorted by price, that we're taking the top object and we want the top 2. And for each of these, we're going to generate a card and put a little spacer between each card and add it into our UI layout. So that's how that looks. And if you can double check something about my presentation mode. Okay, yeah. I'm just going to tweak a little something extra. Etienne endlessly tweaking things. That's how sometimes that works. What I wanted to try out at this stage, bear with me a second, is this right here. And how's that looking? There we go. All right. I'm going to keep presenting still, but I wanted to have a little bit of an add-on here. Actually, no, wait. Sorry, that's wrong. Never mind. I'm going to keep going with this. All right. Okay. Thank you for being patient. All right, cool. So next up, what are we going to look at? So with XML, if we, as I mentioned already, when you wanted to update a widget, you needed to change its internal state manually. So the difference here with composable functions is that when our source data changes, we can call our composable functions with that new data. So that's going to cause a recomposition to be triggered. And when this happens, Compose will smartly call only the parts of the function tree that are impacted by the change in that data. So what does that really mean? Like if I look concretely at this slide and the text on it, like and the code on it, sorry, what we want to look into is as follows. So let's say that we have this product card and we want to be able to press on the click button right there, right? So what we can do is create this object that's called price formatter. And we call this function called remember. Now what remember does is it creates basically this concept of state and mutable state around the price formatter itself. So if we look into the code, what's going to happen here is that this formatter here at the bottom, right, is the one that's going to be used to create the text that goes into the buy button right there. So by remembering this, if we're going to make sure that we only change the card when the price of the actual product is going to change itself. That's the interesting bit. So like what we want to do here is to really lean into this feature of Compose where it's going to smartly call the parts of the function tree impacted by the data change and nothing else. If we called it any different way, then we might end up with a refresh of the tree for no good reason if anything in the object itself would change. All right. So, all right, cool. So the key idea here is to note that smart recomposition systems, it does the things its own way. So Compose is actively going to try to run as few functions of the Compose tree as possible. So some of the things that are caveats here and things you have to watch out about is that since Compose really tries to only run the Compose functions it needs to, it's going to pay attention to the state that these renders are based off of, and it's only going to call those to be recomposed whenever the data in your object changes. So that means that some of the other functions that you might have defined that have not been impacted by changing data will not be called. That's very important to keep in mind. The other thing that you need to keep in mind is that you actually can't assume anything about the order that in which your composable functions are going to be called. So what does that mean? Well, if we think about our prog card a little bit, if the price changed, right, and say the title also changed, you can't necessarily assume that Compose is going to run the title change recomposition before the price change recomposition. So if you write any kind of code that depends on the order in which these things happen, you're going to be in trouble. And the other thing to note is that functions can run extremely frequently. So if you're doing animation, that means that you need to be sure that your functions are very effective. So that's something to keep in mind that you might not have had to deal with before. All right. So the other rules of what you must avoid that are sort of corollary to all of this is that when you're you have to really avoid directly writing to a property of a shared object. That's a big no-no now. You directly updating observables in the view model, that's also not something that you want to see happen. So effectively, if these things are mutative, they're going to bite you in the butt. Things like updating shared preferences and so on, that all types of side effects from within your Compose functions, those are big no-nos. You can't trigger those or you're going to get into trouble. All right. So in the previous slide, I had a bullet that outlined unidirectional data flow as a way to avoid side effect. Now, you might not have heard of what is unidirectional data flow. If you haven't heard about it, it sure sounds fancy, right? And well, the key is that it's really, really pretty basic, and most of us are already using this concept somewhere in our apps. So what do I mean here? Well, unidirectional data flow is a UI update loop. If you've been to one of my talks in the last year or so, you've probably seen this graph before. So data flows only one way. That's the key concept. So what you want to see happen is that your display shows information. The user presses on buttons on that display, triggers events, and these events are then propagated somehow to your app state, which could be in the cloud, in memory, whatever. We don't really care. But the important part is that changes based off of the events are effectuated in that model. And when that model changes, those changes will then back propagate again to the display through some mechanism. It could be LiveData's, RxJava flows, what have you. But the idea is that information only flows one way. So, by having the users look at the device, interacting with the device, generating events, things are good. And, so right here, what I've done is I've put actual names to this, right? Because it's a pretty abstract concept. So in our example today, the view is the Compose UI. And the Compose UI, when button presses will happen, will generate UI events, which we'll call event handlers. And anytime one of those event handlers is called, they'll trigger a change. So for our first example, and we're going to dive into code at this point, the idea is that we're we're gonna use LiveData as the primary channel for this, because that's usually what you're first exposed to as an Android developer when you start out nowadays. LiveData are the way that we can emit changes and propagate those. So let's actually jump into a code example right now, and what I'll do is I'll be taking questions at the end of the talk. Okay, so what we'll do is, like, I'm just gonna note down the time at this stage. Okay, we're not doing too bad on time, so we'll do about like something like 15 minutes per example. I'll do at least the first example, then the second, and then depending on time, I think I'm gonna open the floor for questions, and we'll move on from there. All right, so again, with my little share screen setup this time around. Right, so what I like to do is turn off the share screen and switch to this guy. There we go. All right, cool. So could somebody confirm in the chat at some point when you have a chance that you're seeing the code screen and my picture at the bottom right, and that the font is big enough to read? That's actually, you know what? I'm not even going to assume it is. I'm going to change it up right away. Slightly bigger. If it's not big enough, let me know. I have all the settings in the world to make that happen and make it hopefully readable. All right, cool. So this is our little app. I'm gonna sort of focus a little bit more on what we're looking at right here. So very simple app. It's got a main activity, and I lied, it's not that simple. Anyway, we don't care about the rest of this stuff. What we're gonna be looking at today is mostly the main activity and a couple of the models that are linked to it. So let's get started right here. Main activity. The other thing we're going to do is I'm actually going to start this app. If memory serves, it's ready to go as an empty screen, as when we first run it. So I'm going to do some fly on the wire type stuff right here, and just start up my shared pixel screen. Hopefully no private information out there in the to-do list. You guys don't care about that. Okay, I'll just put it on the right screen, and there we go. So you should see all of this. Again, interrupt me if something's wrong. Yes.
Can you make the font a little bit bigger again?
Yes,
please.
Absolutely.
Thanks.
I'm happy to do that. And thank you for reacting to that. So, and somebody, wait, did that help at all? People in the chat, please chime in. Is this cool? Yes. All right. Feel free to say no. Bit more. All right. Cool. Thank you. I like how the crowd is dynamic. That's good. Awesome. Thank you for being awake. All right. Let me just double check my little color setting. So is this the easiest way to look at that? No, just font. Yes. Okay. Color scheme font. Mouse space 20. We're gonna go with 24. There you go. Make sure everybody. All right, this should work. Okay, cool. Hopefully everybody's good with this. Yeah, all right, cool. At this point, it's hard for me to actually check the screen. At this point, it looks good on my feed, so I'm gonna assume everything's fine. But please complain if it's not. Okay, cool, let's get started. All right, where was I? Okay, I wanted to run this app, right? And just double check that the setup works. Now, I have to make sure that we're going to need to run the right thing also, which is kind of helpful. And of course, for some reason, it's not even proposing that I run this thing. It might just be that I need to be honest, I have not done a dry run of this code since the last time I presented it, so it might be a little bit picky. But we're just going to start with the code and then assume that everything's going to work out fine by the end of this. Cool. All right, where was I? Cool. So, right, a few notes. Like, what if you haven't made any, if you haven't done any Compose programs in the past? So the way this works is that we call set content, very much like we used to with the old XML stuff. And Oh, that's going to be fun. I can feel it. Using an incompatible version of the Android plugin. I can hear people in the audience groan, even if I can't actually hear you. I suspect it's going to be an easy fix. I'm going to actually do that fix right now. I'm interested to know which one are we on for this guy. You know what? I think okay, good. That's what I like when we're being told. It's perfect. And we don't need these guys right now today, although we might. You know what? I'll just leave it in. All right, cool. And we're on alpha 5 as far as I can remember for this example. Please bear with me as I find my way through all of this. All right. Well, it did start, so that's the good news. All right, cool. Back to our example. I'll just try to make this thing a little bit less busy. Oh, this is fun. We're having all the issues. All right. I know how to fix that one. We'll be good in a few seconds. I'm just going to go on with the code, not get too distracted. All right. So what I was getting to say is that when we're using Compose, we just call our set content as we used to, except it changed a little bit now. You might notice that we're passing in a lambda. And inside that lambda, we're going to add our composable functions, and that's going to be the basis of our UI. So for now, the first thing we have here is my composed theme. So it's your basic run-of-the-mill material theme. It's defined as part of like your basic template project somewhere else. But if you dig into Compose, it's kind of interesting is that regardless if it's your own theming, in this case it's our own function, or somebody else's, you can actually dig into the code and see what's behind it. So if I look at my Compose theme and for some reason say I was curious to see what's happening in the OS layer behind all of this, you can click through everything and look at the documentation and basically find out a lot of stuff about how Compose works that way. So the documentation is actually really, really good, excuse me, if you focus on the Java doc that's being given to you. Well, the bad news here is that depending on your version of Android Studio, there's been a bug crawling around a little bit in the last few months where that Java doc doesn't always pop up depending on the version of Android Studio you're using, combined with the Compose version and all that. These are kind of things that get ironed out regularly, so don't despair, but you can always dig into the actual source code and find out what's going on behind the scenes if you have trouble. All right, like getting back to our main example now. Interesting. There we go. All right, so we're going to add a new example. So I'm going to start that one up. And so I'm cheating a little bit here. I'm using the good old Martha Stewart kind of kitchen approach. I have like 3 different turkeys that are ready to go in my examples. And I'm just going to go with the first one, which is our live data example, right? So for our live data example, I'm going to start a composable function, and I'm going to park that one in our UI section right here. Create a new Kotlin file class, which is going to be just going to be a file, and called live data example. Right, very simple stuff. So how do we start a new composable function? We always put the composable annotation up top, right? And we just declare a function. Now, in case you haven't sort of caught that yet, and I haven't explained it, so that would be normal, the @composable attribution here is going to, behind the scenes, do a lot of compiler magic to turn your function into something that can be processed by the UI. So that's very important to put that there. All right, so we're going to start by attributing a model to all of this. We're just going to use a super plain view model here. We already have one ready to go here that's empty. And we're going to provide that through the view model interop here. So that's, I will show that up. That's something that Compose gives you to be able to build the view models and provide it into your composable function. So that's part of what Google provides to hook up to your view models with Compose. All right, so what we're going to do here is we're going to be showing a product. We're going to get that product through something called the, well, basically getting it from the view model. Now we're going to need to get something here because we don't have that yet, right? So I'm actually going to jump into the view model itself, and I'm going to complete what we need here to be able to work. So for our view model to make any kind of sense, we're going to need a product of some kind. So right there, what I'm going to be doing is I'm going to add, I'm going to do that a little bit more quickly. So we're first adding our actual product backed by mutable live data. So if you're not familiar with live data, they're effectively, they hold your state, and whenever that state changed, they publish that state to whoever's listening to it. In our case, it's going to be Compose listening to changes to products. And for actually showing something into the view, we're going to have to actually back that up with something that is exposed publicly. So the way we're going to expose it, we don't want to expose a mutable live data because we don't want everybody and anybody to be writing changes to our model. We want that to be something that belongs internally to the view model itself. So what we do is we take the underscore product and expose it as a read-only non-mutable live data through the actual public product val right there. All right, cool. So it's not going to be a very interesting example if we don't have some sort of mutation going on with our model. So we're going to add this function that allows us to change the name of a product. So on a name change event, we're going to receive a new name, and when the name changes, what we do here is that we're going to take the current product value. So we're going to take the mutable live data, and then that mutable live data holds a product, right? And if you're wondering here, this is an array of predefined products that I created before the talk. So these objects, these products, we have one of them that's stored in there. And it's as it is stored, we can get from the product the actual value of the product, like the actual current product that we have. And to make changes to it, what we do is we use the Kotlin copy function. And using the Kotlin copy function is nice because it creates a new immutable copy with some changes done to the object. And so we are not ending up with like a full stack of mutable objects that we're playing around with, which is inherently dangerous. We're actually just creating immutable copies of things. And when that new immutable copy is created, we assign that value to the mutable live data. And that change is going to become public through the non-mutable, the static one that we have right here. So that's it for our model. Not a whole lot of code. If you're not familiar with these approaches, maybe there's a few things going on. I'll be happy to answer questions at the end around that. But that's like basically unidirectional data flow in action. If you're looking at the model, there's a way of inserting changes in there. There's a way of consuming these events whenever the onName change event function is called. And there's a publishing part of it through the live data, which outputs this stuff, right? So if you go back to our diagram in your mind, you have the model, we have incoming events, and we have outgoing changes to it. And that's our unidirectional data flow right there. Cool, so at this point, what we want to do is jump back to our live data example, a composable function, and finish fleshing that one out. Now we have everything we need. So now that we actually have a product in our view model right here, right? What we're going to want to do is take that product live data again. It's not like an actual copy of the product. And what we do in Compose to register to this flow of changes, this flux of changes, this stream of changes, they're all good synonyms here. We call a function that is provided to us by Google, thankfully, called observe as state. So observe as state is effectively something that we can, the small problem here, we do need to start off with like a default object. It's not clever enough to take the first, well, actually, no, I shouldn't say that. So if you know how live data work, live data are backed by Java and can always be nullable. So they can actually hold nulls. And due to that, whenever you want to use a live data as a source of information, well, you often end up being forced to give a default value. So in this case, we're just going to pass in a product, a default product like this. And this is going to do the trick for us. Now, I'm absolutely honest, I'm not too sure where I'm getting all the red squigglies right here. I'm just going to double check that I didn't do some sort of typo. Just going to copy over my code, and I'm going to cheat a little bit more. I'm just going to get all the right imports that we need. And then I'm going to assume if it's still not happy that it's just one of those Android Studio needs to refresh to be happier in life, which is very likely. Okay, so I'll take this opportunity to fix that Gradle setting import. So this is live. This is slightly maybe disappointing that I'm doing all this editing, but you know what? If you're going to be playing around with this stuff, you better get used to changing the versions of your build files constantly and every other week. The thing is that Compose is in active development, and yeah, like basically if you want to play around with it, it's good to be used to just keeping everything up to date obsessively. Now it's going to do its little dance, and we're probably going to start seeing those red squigglies go away and get nicely highlighted code. Meanwhile, what I'm going to do is I'm going to start really showing off what we are going to be looking at here. And I'm just going to add a column and actually put up that product card in there. So we have a product card that's already defined. If I jump to it, it's still updating. I'll give it a few seconds to catch up here. But basically, I'm going to use the product card that I showed in the slides earlier to back up our thing. And we're going to add a text field underneath that. And just a raw text field, nothing fancy, that whenever you edit it, it's going to push the change straight into the object, and we're going to hope to see that change propagate in the product right after that. All right, so just to keep in the interest of time, I'm just going to copy paste all this. That's the text field. We should be good with our imports. So I'm just going to try to run this and see if that's going to help Android Studio. The other thing with Android Studio is that if you've ever actually worked with it, you're probably familiar with the fact that it's not always very happy when you start changing libraries on the go like that. So it probably needs to reindex its things. I'm going to hope that's the problem and not some other mistake I'm making somewhere else, but we're going to find out in a sec. So let me just unlock the phone right there. Well, that's nice. No, so I don't show everybody my nip. Sorry. All right. There we go. Cool. So we're still building the app. Hopefully this is going to compile and run. We'll find out in a few seconds. So while we're trying to find that out, I don't want to make everybody wait. So I'm just going to look at the chat for questions. Like people, I encourage you to start asking questions right now. I'll do my best to answer them while Android Studio is sorting out its things. With a little bit of luck, it shouldn't be that long. Now, you could ask me, I'll ask on your behalf, Etienne, is it always this long to compile Compose examples? The answer is no. So it's one of our first runs. I haven't compiled this in a while. We just changed all the API numbers. So it's doing a fair amount of work right now, but on average, it's actually pretty snappy to work with Compose. What's nice, and I can probably show this towards the end when I'm done with my examples, is that there's usually ways to preview what you've done in Compose and actually look at the layouts without necessarily recompiling everything every time. So something's wrong, as sometimes things happen like that. And what's the going on version right there? It's not happy with versioning. Big surprise. And that's probably a reasonable thing. So bear with me, I have an easy solution. We have another turkey in the oven that's ready to go. So I'm just going to apply the changes I have from one of my latest versions. And maybe you're just going to bear with me a little bit more while I go to my ultimate example and I just fix straight off the bat from there all my examples. Keep that really snappy. Yeah. checking everything. Oh, I see it's gone. Sorry about that. Right. Now we're going to get the right thing. Okay, cool. So I have a few things I need to change in the build files. And you know what? I'm not going to try for hours to do this. I got it already ready to go. So if you give me a second, I've just updated everything. We know that we have a rather modern version of our Gradle build system running right now. So with this, I think we should be good to go. Let me try again. And if that doesn't work, we're just going to keep with the code samples, keep going with them, because at the end of the day, it doesn't matter that much if the thing runs. It's just a nice to have. Right. So I'm just going to double check in the chat if there's any question. Yeah, those problems are always kind of painful to solve. All right, so I'm just going to move on a little bit to the next example. So the idea here was that we managed to create a consumer of events with the live data, and then also managing to emit those events from that live data. And that once we get this running, you'll be able to see that we have a card, and whenever we edit, it updates live, and everything is nice and tidy. And the hooking up of things was not very complicated. That's live data. The problem with live data is that they're, fairly effectively production ready, in my opinion. That's a bit harsh, but live data were provided as this is better than nothing. We know that not all Android developers are allowed to use RxJava or Flow or what have you streaming library in production at their company. Sometimes it's not really practical. Not everybody is aware of these best practices. So live data is, in my opinion, and from conversations I've been lucky enough to have with Android engineers, I think we're introduced as sort of an RX light. They're basically the thing that you should use that's not too much of a foot gun, that Google can clearly promote and introduce into their own dependencies, and that you can use to get the streaming library for changes. And I'm just gonna, right, so this is just, it's having none of it. I'm gonna do the good old clean and rebuild project, and then we're gonna still keep going with typing up the examples while that's happening. Actually, you know what, I'm gonna do like a straight up, give away everything from this, and then I'm not gonna go with the full invalidate, because you folks have other stuff to do today. You don't want to stay here for like 3 hours looking at my build system, because that's not interesting at all. All right, so while this is going on, I'm going to move forward. All right, so if I go back to my keynote, so I'm not even going to bother really jumping around too much. So the other thing we want to look at is how would we make this example work with RxJava? And once we're done with that, I think we're going to call it a day, because as things have happened, things are a bit longer. So how would you use RxJava with Compose? And the example for RxJava will apply very nicely to Flow. And I can actually show some sample about that later, but it's pretty much a one-to-one as far as like the code samples go. You just swap in the libraries and pretty much looks the same. Right, so how do we correctly use RxJava with this setup? Well, this is going on now. Again, start a build just to try to get it to run. All right, so is there a legitimate error here? No. All right, never mind. So, yeah, to be honest, like this big ass font, I'm not seeing where the problem is. I can't really get it. Solve reference. All right, and, I don't actually know what's going on with this. Right, cool. Just move on to the other example. So, all right, cool. So we have our live data example. And then to follow up with that. All right, so for RxJava, we're going to slightly change our approach. So we're going to use something called a model store. Model stores are something I've been using for a long while. I'm not going to explain how to build one from scratch today. We're just going to basically see how it works when you want to use one. So I'm going to start with this. So to get started with one, what you need is basically something called a publish relay. Publish relays are RxJava constructs. Well, specifically Rx relays. Usually we would use subjects if we were using pure RxJava, but in this case, there's this nice little library that adds a few affordances that make things easier for us. And we're going to really use that right away. So what this does is it keeps a copy of something. In this case, the type is S because we don't want to specify it. We want it to be very generic. And it keeps a copy of S very much like a LiveData, except in a way just cleaner. LiveDatas have their own technical limitations. I'm not going to go and deep dive on right now, but they basically relays do not have those limitations. And on top of all of this, what we're going to do is we're going to create this little construct called a store. So we have a relay that basically brings in all the events. Now we're going to use it to consume the events. And the store itself is where we're going to basically have our state, apply event changes to it, and then broadcast those from the store. And there's a few boilerplate here things that go in, but basically what we want is we want to make sure to handle all these changes on the main thread, because these changes should be snappy. They're just basically changes to the object. They're simple copies. No big heavy work is supposed to happen on these model stores when you modify things. And we use the scan operator to make sure that it starts with an initial state and that every time there's an event, we apply these changes to the object and they're being emitted, right? And then the two functions we're missing to implement our store are the process function, which accepts something called a reducer. We're going to go look at what that is in a sec, but here's a hint that if you remember the copy function that we used earlier on the data class, it's pretty much the same thing. And we have the actual model state observable, which is how you're going to consume from the model. So process is the input function, model state is the output function. And if you think back to what we have in our live data example, it's pretty much exactly the same thing. Product here was the output live data. Sorry, this guy I'm talking about. The product that was right here was the output part of things, and then the input part of things in the view model was this function right here that we would call. So with our observable model store, just upgrading from that, we have like a processor of anything, any command that you might want to give. And we have a stream that outputs any type of data. So it's really just more like our last example, but more generic. And if you look at a reducer, what is a reducer? It's effectively only a function that you call on something that turns into something else. So in our case, it's the data class that we would call copy on with a slightly changed parameter, and that we get the new parameter. That's effectively what we're talking about. All right, so once we have this, we can jump and create something called a product observable store. So the product observable store is just a store of our product object. And once we have this implementation, what we need is to just basically take a copy of this, specify what type of thing we're holding in this case, a product, the same product that we used for the live data. And and then we just create our singleton here. Like, I'm not going to talk about how the singleton is created. That's not interesting for today. All right, cool. So once we have this, we have everything we need to hook up to our composable. So we're going to go back to our main activity, and we're going to change a few things, not a ton. Right. So for our Rx example, okay, cool. So we're jumping back to the main activity. Now we're going to, yeah, that would have been helpful if I actually would have called the sample earlier, but we're just going to move beyond that right now. All right, cool. So what we're going to do here is we're going to add our observable store straight in there. We're going to get it through inject here. Choose the toothpick index. So that's like a little trick to just get a copy of our observable store. There's a single copy for our whole app. And that's our main model, basically. We're going to talk directly to the model. We're not going to go anything fancier than that. And so we're going to create our composable RxJava function. So creating our RxJava example. It's really a small difference really from what we've done earlier. The idea is that we're going to be passing in a subscribe as state object, and we're going to look at what that is in a sec. And we're going to have something called a processor, which is something where whenever there's an event, we're going to emit that event through that thing. So this is a function that we pass in, and whenever you click on a button and you want something to happen, we're going to call that processor function, and we're going to give it the job it has to do on the model. We're going to say, okay, you need to increment value X by 1, for example, right? So if we go right ahead and do that, like what we're going to do here, I'm just going to add the code right there. We're going to look at it for a sec. So we're going to use the subscribe as state function, right? So this basically is taking a state object, which is a compose type of object, and by saying give us the value, give us a product from that, right? And here, this is how compose works with this. So by basically saying take the state attribute parameter and give me a product out of it, compose is smart enough to understand that this is something that will change in time. And whatever it changes, it's going to call the RxJava composable and recompose it. And that's by due to the strength of us having used that state class right there. So very quickly, we're just going to finish that up. You know what? I'm just going to save us all a bit of hassle. I'm going to add all the imports that we need. Boom. Okay. All right, so we are actually missing a few things here, but in the interest of time and just like being able to answer questions, like we're missing a name edit field. So that's just basically the text field that's editable like we had earlier that's been put in its own composable function. So I've added that right there. And then we're missing a few other things. So I'm just going to add those in. We were missing a name change, right? So that's just a reducer. So that's whenever the name changes, this is us creating a reducer that we can pass into the processor below. So if you look at the processor here, whenever our name is going to change, it's going to trigger an event on that. And if you look at the processor here again for the 2 buttons that we're going to be adding to the app, these impact and they apply a price change to our object. So now, just to close on this, because it's getting a bit long, what I'm going to give one last try to actually get this to run so that we can have a visual reference to all of this. I'm going to take the project as I had it the other day, and I'm just going to check it out as is, drop all the current changes that we had today, and we're going to try to just, this kind of changes, boom. Just going to try to make sure. It's not happy with that either. I understand. I'm just going to work quickly with this. Yeah. A bit too long. I'm just setting myself up. Okay. All right. So I'm jumping back to what was previously a working version of the project, because I had such a thing at some point, and we're going to try to run that right off the bat here. If that works, then I can at least start putting debug points in there and showing a little bit how these things work when they actually do work, which is a bit more interesting in my opinion. Yeah, we're going to give it a chance. So meanwhile, if anybody has questions with this demo that's not been going the best, to be absolutely honest, but if anybody has like precise questions on things that I would have blurred over or not really gone into enough in detail, please ask them right now in the chat, and I'll try to prepare a sensible answer out of it. So Serge is saying that Rx and Compose together are pretty fancy and powerful, and yes. What I like about the setup, though, is that if you really look at this code, there's really not a whole lot of it, and that's actually a very good thing, right? So if you think about it, Compose is only concerned with rendering a UI to screen, right? And In this case, all we need to pass in is effectively this wrapper around the product type, the model that interests us, the class that interests us. And if we dig into the state itself, it's going to let me just travel to that. Yeah. So this is a Compose interface that we get. And all this is like, it's a wrapper for values. So it holds a value of a certain type, and whenever that value has changed, it triggers a recompose in the Compose system. And so that's interesting because then you can basically stop thinking about all this wiring when you're starting to write your compose functions, right? Like nothing in our compose function here says, except the name, that it's an actual RxJava data source, right? We don't know this. The only thing we're aware of is that we have a data source, we have something that holds data X, and then we also defined ourselves a way of communicating with the external world and sending events down some pipe somewhere that we don't know about. Like this function is extremely simple, right? All it takes is a reducer. You could pass in different types of handlers if you want to be a bit less sophisticated and a bit like not use reducers and all these concepts. You can just have your handlers there, pass them in, and that's it. So that's kind of a very interesting, powerful way of hooking things up. I really think it's one of the big killer features of Compose. Like it's going to be very easy to hook Compose up to a modern a modern architecture. Now, we've run through the whole build, take 2 minutes, and it looks to me that there was some sort of mistake, and we're going to get a proper running program, or not. Ah, good. The joke is not on me. Okay, cool. So this is the fully running example. Hopefully, I'm going to double check everybody sees this. Yeah. So at this point, I'm actually going to run it in debug mode and just show everybody what's going on here. And we're going to put breakpoints in there. So we could see the card for our one product, right? It's going to come back. I'm just going to put breakpoints at the handler itself, right? So we have the editor button right there I'm highlighting. So we're putting the breakpoints right before we call the click handler here. And then we're going to play around with that. So we're going to up the price by $1, right? Just make that a nice round number, scary number, and the breakpoints are not triggering. Well, that's life sometimes. But effectively, the idea is that the processor is being called, and when the processor is called, it's just like does its thing, pages the model. But what you can see, without a doubt, is that the change to the product that occurred here has been applied to the price, right? We can see that I can sort of make the estate slightly more expensive and slightly less expensive by the click of a button, and that this composable, when state of product changes, and state of product, again, the source of this was our subscription to in Rx Flow. And subscribe as state here, it's important to note, streaming and observable of products. And this is a compose function that we're getting that plugs into RxJava. So it's not something I wrote, it's something Google gives us to just connect to our RxJava streams. Cool. So demo worked somewhat. I don't know. It's like I must have mucked up some build file between all my changes between the trees. Cool. So questions. Can we consider Kotlin flows over Rx and LiveData? For sure. And that was the third example. And as I've learned now, I can't give this presentation fast enough to cover that. I do have the code pre-baked and ready, so I can probably just show you what it would have looked like. If you give me a second. So with the third example completed, I'm just going to jump around a little bit. Now, right. Flows are effectively the same thing. Like I've shown you an observable and a composable method that we called on that to get a state. So in the case of flows, it's not much more complicated. In this case here, I have a different type of model store that's backed by flow. If you look very quickly at how it's written, it's basically the same thing I just showed you with Rx, except it uses coroutines and flow. And old practice that's not great, that should change. In this example, I'm using channels. If you don't know what those are, you probably don't care that I'm using them. If you do know what they are, the proper object to use nowadays is a flow store or anyway, it's a new storage of data primitive that we can get with Flow. that replaces effectively the user channel in my little builder, but you don't really care about that because that's invisible under the hood. If I changed it, it would not actually impact the rest of the app that much. But yeah, so this being a flow, you can see here when you call the model state, right, you get a flow back, a flow of products in our case. And if I jump back to our main activity, right, very, very close to what we were doing with Rx. We just basically take that product flow, we call it, we get it, and then we collect as state. And again, that's the compose function that we're getting. The only difference here is that we really need to give it an initial state. Yeah, that's about it. Cool. All right. Yeah, that's it for me. So how does Flow compare to Rx? That's a good question. So I'll go with the pros and cons of why you would use Flow over Rx. So Rx is effectively a very nice library. It's been around forever. It's totally fine for production. If not, you could almost argue that it's more aged and it has more battle tested, is what I want to say, than Flow. But it does weigh in at about 5 megs for the APK. So when you start thinking about it, oh, okay, that's big for an app. Wait, is it 5 megs? It's at least a solid meg or two once you've pro-guarded it and everything, right? So there's a fair amount of size involved with having RxJava in your project. And then you're going to ask me, Etienne, how much does Flow weigh? And the answer is actually very, very little. It's part of the system. It's part of coroutines. You're probably going to have coroutines in your app anyway, right? Alongside Rx. So you have a primitive that you can use that gives you everything that Rx would give you, and that is baked into the language, and that weighs in at about, if memory serves, something like a few hundred Ks. So that's like tenfold less. And also, the API is a lot more Kotlin idiomatic, right, than RxJava. It's RxJava, it's not Rx Kotlin. So it's mostly a question of taste to a certain extent. And yes, there is a certain, like performance-wise, they're comparable. And so size is the big factor, and idiomaticness is another big factor. And then it gets into more philosophical questions like, well, everybody should know the language primitives, and should we expect everybody that comes into our company to know a new library? And at that point, Flow starts to look really good. And also, you don't need to learn multiple systems. Like if you learn Flow, you're going to be also getting into coroutines. And once that knowledge is baked into a developer, I mean, they're going to carry that with them. And it's not going to be something that you need to import in every other project, right? It's going to be something native to the platform. So that's why most people are doing the switch, really, in my opinion. All right, cool. So I'm done.